Hello, we will calculate shear force diagram and bending moment diagram of this simply supported beam. Total span is 2 plus 3 plus 2 plus 1, 5, 6, 7, 8 meter span. And at a distance 2 meter from A, point load 50 kilonewton acts, and at a point C, 100 kilonewton load acts from point A, it is 5 meter distance. And at point, this D point, 150 kilonewton load acts, and from E it is 1 meter distance. And uniformly distributed load also acts on this 8 meter simply supported beam throughout 25 kilonewton per meter. And at A it is hinge support, and at E also it is hinge support. So free body diagram, that means we remove supports and take reactions. So horizontal reaction X, vertical reaction AY, this EX and EY. So judge first shear force diagram. So see, 25 kilonewton per meter load is throughout, and this 150 kilonewton, 100 kilonewton are maximum load towards this D point. That means shear is maximum here. As per my judgment, we will calculate values also later and correct it. So this AY is upward, so this is upward. This is, yes, this is upward. This is UDL, that means this is inclined line. This 50 kilonewton is downward, so this is downward. Again BC is uniformly distributed load, so it is again inclined line. And at point C, this 100 kilonewton is downward, so here downward. And between C to D, this is also inclined, and this 150 is also down, and this is like this shape. This is negative, positive, and this is maximum at point D. So now see, this is pin support, that means here moment is 0 at point B, and between A to B it is UDL. So UDL, it is parabolic curve. So this is like this up to point B. Now up to point C, point C shear is 0. That means here movement is maximum. And point D, it is again like this and like this. This is positive, and here at point C it is maximum. So let's see first reactions AXAY, EXEY. AX and EX are 0 because there is no horizontal loads. Only we are interested in vertical reactions AY and EY. So AY plus EY, minus 50, minus 100, minus 150, and minus 25 into 8. this is 500 kilonewton. Total vertical load is 500 kilonewton. Now take moment at this E point. This AY is clockwise, so AY into 8. Fifty into 3 plus 2 5 plus 1 6. AY is 50 is anti-clockwise. 100 into 3. Total uniformly distributed load is 25 kilonewton per meter into 8 by 2. Put this AY value in equation 1 and calculate EY. So here at point D it is 306.25. That means our judgment is correct. And here 193.75 kilonewton. Now calculate shear SFD. Shear force at point A is 193.75 kilonewton. Calculate shear force at this point B. For calculation of shear force at point B, AY is vertical minus 25 into 2 and at left 193.75 kilonewton shear force at B towards right is this 193.75 positive minus 25 into 2 and minus 50. (93.75 kilonewton). Shear force at C towards left. This 93.75 minus 25 into 3. (18.75 kilonewton). Shear force of C towards right 18.75 kilonewton minus 100 kilonewton. Minus 81.25 kilonewton. Here it is 0 and at point D this is E. Minus 81.25 and this is 25 into 2 minus 25 into 2. Minus 131.25 kilonewton. Just towards right. Minus 150. Minus 131.25 minus 150 it is minus 281.25 kilonewton. Shear force at this is D. This point is D. shear force at E, just left, is minus 281.25 minus 25 into 1. It is minus 306.25, and shear force at E is positive 306.25 kilonewton. So it is correct. So now next we will calculate bending moment. So bending moment at A equal to 0 and bending moment at E equal to 0, because both are simply supported. Now calculate bending moment at B. This AY is 193.75 into 2 positive clockwise minus 25 into 2 concentrated load into 2 by 2. It is 337.45 kilonewton. 337.5 kilonewton meter. Now next is at point C. This 193.75 into 5 minus 50 into this 3 and minus 25 into 5 into 5 by 2. It is 506.25 kilonewton meter. This is B, and C it is 506.25 kilonewton meter. And at point C it is maximum. Bending moment at D is equal to, take bending moment at D from right hand side, and when we take bending moment from right hand side, what value bending moment, if it is coming 200 positive, then convert it into negative. If it is negative, then convert it into positive, because we take bending moment from right hand side. So for this point D, this EY is anti-clockwise, minus 306.25 into 1 and plus 25 into 1 into 1 by 2. It is minus 296.75 kilonewton. Convert 306.25 into 1 minus, take moment at D. EY reaction is vertical, but it is anti-clockwise, so minus sign, and EY reaction is 306.25 multiply by 1. 1 is distance between reaction to that point where we take bending moment, and this 25 kilonewton per meter load is vertical load. It is clockwise, that means positive 25 into 1 into 1 by 2. It is 293.75. This value is minus, but I take positive because I take movement from right hand side, because it is easy for me to calculate. And at E it is 0. So values are 337.5. This is 337.5 kilonewton meter. This is 506.25 kilonewton meter, and this at point D is 293.75 kilonewton meter. So calculate this also in StatPro software. So this is 337.5 kilonewton meter. This is 506.25 kilonewton meter, and at point D it is 293.75 kilonewton meter. That means our judgment is correct. So see in StatPro software 0 and 8. Let's define some properties because of errorless analysis. We don't calculate bending moment for dead load, we only calculate bending moment for live load. But we need to define this material and section properties also in StatPro because of errorless analysis. So this is one is hinge support and other is also hinge support. So only X and Y reaction comes. This is 2D analysis. Now loading. First we will put concentrated point loads minus 50 GY direction, minus 50 because it is downward direction load, and it is D1 is 2 meter. So add again another load is minus 100, and this load is 5 meter from point A. Third load is minus 150, and this load is 7 meter from point A. And one another load is movement, uniform movement. It is minus 25, and it is throughout. This is not movement. uniformly distributed force. In member load it is uniform force, yes, minus 25. So analyze it. Our objective is to cross check bending moment and shear force, manually calculation and software calculation. So there is one error. Error section properties not enter for member 1. This is properties, this is section, assign to view, assign, yes. Okay, let's analyze. Run analysis, save. Post processing, done. Load, live load, apply, okay. So, see first movement. Now see deflection of that beam is like this, and in STAT Pro it is also like this. But see, deflection is downward sagging, that's why sagging bending moment comes positive. But here see STAT Pro tells us that it is downward. So I tell you that STAT Pro negative values are sagging bending moment values. See 0, 0, 475, 498. Why it comes 475, 498? It's not match with our 50 kilonewton. Let's see shear. See reactions. 193.751, 193.75, and 306.25. Reactions are okay. Now shear. One 93.75, 43 point. See shear this Fy at 2 meter distance. It is 93.75. That means our see 93.75 at 5 meter it is minus 81.25. Yes, it is correct. And at 7 meter it is minus 281.250, minus 281.250. And at 8 meter it is minus 306.250. That means our manual calculation and software calculation both are matches. Now let's movement. See, at 2 meter, this mz is minus 337.501. See, 337.501. Our movement is positive. This is difference between manual calculation and StatPro calculation. StatPro considers sagging movement as negative, but we, while calculation of bending movement manually, consider sagging movement as positive. So stat sagging movement negative and our manual calculation sagging movement positive. This is difference. Sagging positive and manual sagging positive and stat sagging negative. So when we take reactions from stat, and if reaction is negative in stat, that means it is sagging bending moment. And when reaction is positive in stat, then it is hugging bending moment. And while calculation of manually, when reaction is when bending moment is negative, then it is hugging bending moment. So let's check bending moment values. C is 5 meter, minus 506.252. This is 506.25. That means it is correct. Let's check at 8 meter. It is 0. See, 8 meter it is 0. That means our manual calculation and software calculation match each other. So let's learn thumb rules also. See, when this load is towards reaction E, that means shear is maximum at point E. When these loads are towards reaction A, that means shear is maximum at point A. Where load, but that means where in which reaction load is nearer, that for that reaction is maximum. And for bending moment, consider CG of that loads, their bending moment is maximum. And one thumb rule also, where shear force is 0, their bending moment is maximum. So this way our numerical completes. Thank you very much.